Q8939. The primary purpose of a takeoff warning system is to alert the crew that a monitored flight control is not properly set prior to takeoff. The system is activated by A. An 80-knot airspeed sensor. B. An ignition system switch not set for takeoff. C. Thrust lever. The correct answer is C. Thrust lever. The correct answer is that the takeoff warning system is typically activated by the thrust lever. When the thrust lever is set for takeoff power, it triggers the takeoff warning system to monitor the proper configuration of flight controls. The system then alerts the crew if any monitored flight control is not correctly set before takeoff. Q8940. An airspeed indicator measures the differential between A. Pressure and temperature. B. Pitot and cabin air pressure. C. Pitot and static air pressure. The correct answer is C. Pitot and static air pressure. The correct answer is that an airspeed indicator measures the differential between pitot and static air pressure. The pitot tube measures the dynamic pressure of the oncoming airflow, while the static pressure is obtained from a static port that senses the atmospheric pressure. The difference between these two pressures is used to determine the airspeed of the aircraft, as indicated on the airspeed indicator. Q8941. The angle of attack detector operates from differential pressure when the airstream A. is parallel to the longitudinal axis of the aircraft. B. is not parallel to the true angle of attack of the aircraft. C. is parallel to the angle of attack of the aircraft. The correct answer is B. Is not parallel to the true angle of attack of the aircraft. This option correctly describes the operating principle of an angle of attack detector. When the airstream is not parallel to the true angle of attack of the aircraft, the airflow will exert different pressures on the surfaces of the detector. These pressure differences are used to determine the angle of attack. Q8942. 1. When an airplane is slowed below approximately 20 miles per hour, the antiskid system automatically deactivates to give the pilot full control of the brakes for maneuvering and parking. 2. An antiskid system consists basically of three components: speed sensors, control box, and control valves. A. Only one is true. B. Only two is true. C. Both 1 and 2 are true. The correct answer is C. 1. When an airplane is slowed below approximately 20 miles per hour, the anti-skid system automatically deactivates to give the pilot full control of the brakes for maneuvering and parking. This statement is generally true. Anti-skid systems are designed to prevent wheel lockup during braking to improve control and prevent skidding. However, at very low speeds, such as below approximately 20 miles per hour, the anti-skid system may deactivate to allow the pilot to have full control of the brakes for maneuvering and parking. Therefore, statement 1 is true. 2. An anti-skid system consists basically of three components: speed sensors, control box, and control valves. This statement is generally true. An anti-skid system typically consists of three main components: speed sensors, control box, also known as the anti-skid control unit, and control valves. The wheel speed sensors monitor the rotational speed of the wheels. The control box processes the sensor data and determines when to modulate the brake pressure, and the control valves regulate the hydraulic pressure to prevent wheel lockup. Therefore, statement 2 is true. Q8943. In an anti-skid system, wheel skid is detected by A. An electrical sensor. B. Discriminator. C. Sudden rise in brake pressure. The correct answer is A. The detection of a wheel skid is accomplished by the electrical wheel speed sensor located in the wheel hub. This sensor continuously monitors the rotational speed of the wheel. If the wheel decelerates at a rate faster than expected, indicating a potential skid, the sensor sends a signal to the control box. In response to this signal, the control box initiates the release of hydraulic pressure on the brake associated with that specific wheel. By releasing the hydraulic pressure, the system helps prevent further wheel lockup and allows the wheel to regain traction, thereby mitigating the risk of a skid. This proactive action of the anti-skid system contributes to enhanced braking effectiveness and improved control during critical braking situations.